Hi everyone. In this video we're going to start talking about the chemistry of life, and we're going to start with section 2.1 from atoms to molecules. Why isn't that going forward? There we go. Chemistry of life. And hopefully by the end of this you'll know what this molecule is, and we'll leave it to be a mystery right now. So the first objective we have is distinguish between atoms, elements, and molecules. And so to be able to do that, you need to understand a concept of matter. And matter is anything that takes up space and has weight. So just about everything you know, probably everything you know, is matter. So the elements are the basic building blocks of matter. So look around you, every single thing that you see is made of elements. And you're probably familiar with looking at the periodic table of elements. And this is a list of all those elements. And some of them might even look familiar. There's hydrogen, carbon, nitrogen, oxygen, fluorine, phosphorus, sulfur, chlorine, neon, helium. You've heard of a lot of those, and a lot of them that you haven't heard of. But all of these elements are the basic building blocks of all matter. So every single thing that you look at is composed of combinations of these. Over 90% of the human body is made up of only 4 elements, and they are carbon, and you can see that they all have a designation. So carbon's capital C, nitrogen, oxygen, and hydrogen. So 90% of the human body is made up of just those 4 elements. An atom is the smallest unit of an element. And an atom will have all the chemical and physical properties of that element. So we can have 1 unit of oxygen, an atom of oxygen, 1 unit of nitrogen is an atom of nitrogen. And you've seen something like this somewhere. This is a diagram of an atom, and you've probably heard that atoms are made of protons, neutrons, and electrons. And the protons and the neutrons are in the middle, and the electrons kind of zoom around and whiz around the outside of that atom. And we're not going to spend a lot of time on this. Hopefully you've had some chemistry class somewhere, but atoms are way too small to be seen with any kind of microscope. There's all sorts of things that physicists do to understand the existence of atoms, but it's pretty clear that all elements are made of atoms. So here's one atom, or a single unit of an element. And what's going to make the different atoms unique is you can see that the number of protons, neutrons, and electrons are going to vary, and that's going to determine what element you have. So the next word we have is molecules. So a molecule is when you have 2 or more atoms or ions, and we'll mention that later, that form bonds with each other. But we have 2 or more atoms come together, we have a molecule. And when you're learning chemistry, it can be really confusing because we draw molecules out in all different ways. And I just wanted to show you some examples of how you're going to see molecules written. So here are, we're going to talk about a chemical called butane. And actually it says 3 textbook ways, but actually there's 4 ways to draw butane right here. Here's butane right here, C4H10. It means it has 4 carbons and 10 hydrogens. And so this is a molecule. This molecule has 4 atoms of carbon and 10 atoms of hydrogen. It's made of 2 different elements. The elements are carbon and hydrogen. So those words can be confusing, but just practice a little bit and you'll be all right. You might see butane written like this, C4H10, but you might also see it drawn this way, and you can see there's different names, and you don't have to remember the names. But this way they drew it, here's our 4 carbons, 1, 2, 3, 4, and then if you count up the hydrogens, you'll find 10 hydrogens. And these little tick marks are bonds. So carbon's going to bond to hydrogen, and it's going to bond to other carbons. One thing I want you to notice in this, and it will come up a little bit later, is you look at carbon. Carbon actually forms bonds with 4 things at a time. hydrogen just forms a bond with one thing at a time. And that's going to have a important thing when we talk about organic molecules. Now, this same molecule, we can still be talking about butane and draw it this way. So you might see it written that way. CH3, so there's the carbon, and it's got 3 hydrogens. So there's the first one. The second one is a CH2. There it is. There's another carbon with 2 H's, CH2, CH3. So that's still butane. And sometimes people just get sick of writing out all the letters. So especially with carbon-containing molecules, sometimes you just draw these little lines, and at the end of each line is a carbon. So there's a carbon 1, 2, 3, 4. And we know that carbons will make bonds with hydrogens. So an experienced chemist can figure out what that, even just by looking at that, they can figure out this structure. So you're going to see molecules drawn in all different ways. And I put some down here. These are some of the molecules that you should know, you should be familiar with in this class. And here we have 2 hydrogens. So 2 atoms of hydrogens. It's made all of one element, but hydrogen naturally forms molecules because it likes to be stuck to another hydrogen or something else. So in this case, H2 is what we would call hydrogen gas, H2. Oxygen, we have the element oxygen, an O, but naturally it's more stable if it forms a bond with other oxygens. And you'll notice sometimes you have a single bond, sometimes you have double bonds. In this class, I'm not going to go into the details of that. You probably heard about some of that in chemistry somewhere. But oxygen can always bond with another oxygen when it's in the air, and it's called O2. So O2 is the oxygen that we breathe. Here's H2O, and probably most of you know that H2O is water. So there's an oxygen and 2 hydrogens. And carbon, when it's bonded to 2 oxygens, we call it CO2, and that's the carbon dioxide that we exhale. And that's also the carbon dioxide that accumulates in the atmosphere that's contributing to climate change. So it's a waste product of our burning fossil fuels also. So you should be able to recognize that H2 is hydrogen gas, O2 is oxygen, H2O is water, and CO2 is carbon dioxide. The second point in that, one of the second points I want to talk about, second learning outcome, is in section 2.2, summarize the structure of the pH scale, the characteristics of acids and bases, and the importance of buffers. And the pH scale is a scale from 0 to 14. And what it does is it describes how acidic or basic something is. And we have some sense of acids. You know, you eat some food and you notice it's a little acidic, like a lemon's a little bit of a little acidic. Or you've heard of stomach acid. It's a little bit acidic. Sometimes they say, oh, if you're having stomach problems, be careful about drinking coffee. Coffee can contribute to your stomach acidity and it can make it feel bad. Other things like vinegar. You might have heard that using carbonated sodas can be acidic, and you've heard people say things like, oh, it can even take rust off your car because it's slightly acidic. So when you look at the pH scale, you're going to look at pH 7 is going to be neutral. So absolutely pure water is neutral. It's not acidic, it's not basic. If you go below pH 7, it's going to be more acidic, and here's some examples of acids and how acidic they are. And then you go above 7 up to 14, it's going to be basic. And most of the foods, we don't have a lot of foods we eat that are basic because they don't taste good. Acidic things are a little bit sour, and we kind of like that flavor, but basic things are bitter. And bitter is not an appealing taste to us. And it's probably a thing through evolution because there are a lot of poisons can be bitter tasting. So we've developed an aversion to bitter flavors. Let's see, on this diagram right here, it doesn't tell you about blood pH, but the pH of our blood is in the range of 7.35 to 7.45. So I would say the blood is nearly neutral. It's very, very slightly basic. But if you ask, about the pH of blood, I would say it's in the range of neutral. It's much more neutral. And our body goes to a lot of trouble to maintain that constant pH of 7.35 to to 7.45 for our blood. So there you go, acidic and basic. I also had the term buffer there. And here, just when you looked at the previous diagram, we saw that I said that blood pH is 7.35 to 7.45. So it's a very narrow range in which our blood pH remains constant. And it remains that constant because some of the things, we have some chemicals in the blood that are called buffers. And a buffer is a solution that resists change in pH. So you can eat acidic foods, but your blood pH will not drop. And that's because our blood is buffered. We have chemicals in our blood that maintain a constant pH. We also, you might have heard of that term like in shampoos. A lot of shampoos, they say they're pH balanced. And a shampoo that's too acidic or too basic can be harmful for your hair. So they put buffers in shampoos to keep the pH at the level that's most desirable for our hair. If you're looking at your textbook, there's sections called Check Your Progress, and there's questions, and here's the question right here. Explain the difference between a solution with a pH of 5 and a pH of 3. And that actually, so if we go back and we look at this, we say a pH 5 and a pH of 3. Oh, a pH of 3 is more acidic than a pH of 5. A pH of 5 is more basic. But there's also something I didn't tell you. Every unit on the pH scale, so from 5 to 4, is 10 times more acidic. From 7 to 8 is 10 times more basic. So when you're asking me from 5 to 3, 5 to 4 is 10 times more acidic. 5 to 3 is 100 times more acidic. You got to add another 0. 5 to 2 is 1,000 times more acidic. 10, 100, 1,000. So every unit of the pH scale is 10 times difference. So pH 7 to 8 is 10 times more acidic. From 7 to 9 is 100 times more acidic. And so that narrow range of pH from 7 to 8, that's a big difference to the human body, and that can actually cause some negative effects. So our body does a lot of work to keep our pH around that 7.35 to 7.45 range. And on that note, I'm going to stop this video and we'll go to the next one.